Hi and welcome back to our educators. So ini video part 2 lah for displacement of halogen from its halide solution. Okay, so first thing, for this reaction we have chlorine water and potassium bromide. So we are going to study this reaction in terms of how to answer for exam question. So this is can be considered as a practice for your exam. Okay, fine. So I write here lah, exam practice questions. So once I teach this question, what you can do, you can go back, okay, after this class lah, okay, you can try to do for this one. Yeah, I'm doing for CL2 and KBR, right? So you can do for this one, the second example you can do, third example you can do, okay? You can try to explain for me how I do. Okay, so don't see this observation influence all at first place. We're going to do the equation. Okay, so who is my halogen? Chlorine water and potassium bromide. Chlorine water is my halogen because got 2 in the formula, ada 2. Then potassium bromide, KBr, which is my Br is my halide. Betul? So displacement boleh berlaku ke? Ingat, your halogen should be above your halide. Your halide is Br minus, your halogen is Cl2. So yes, can happen because Cl2 is above Br minus. Tak percaya, come I show you. Cl2 kat sini, Br minus kat sini. So can lah. Halogen is like the king, you know. The king should be in the top. So the king is in the top right now. So yes, the reaction can happen. Okay, so what will do? Halogen will travel from here, will kick this Br. Okay, so he will take KCl plus Br kan dah kena kick kan, become halogen back, Br2. So this is the equation. Okay, and then how about the stabilized equation? So you have to balance lah, 2 kat sini and then put 2 kat sini. So done. You are done by balancing your chemical equation. So if people ask you, tell me your balanced chemical equation. So this is your chemical equation. So in the first place, to answer on displacement question, you must do the chemical equation. Okay. After that, you must do the half equation and all the equations lah. Okay, so for Cl2, wait Cl2 is an element, correct? Same family, only Cl family is there. So the rule, the oxidation number rule, the first rule state that the oxidation number for an element is 0. So Cl2 is 0 lah because ini adalah sejenis element, only one family what? Only Cl family yang ada 0. KBr we want to determine for whom? Br lah, because K is my ion pemerhati. It will just stand there and observe only. K won't do anything. My issue is between my halogen and halide, right? So I will focus on them only. So my Br minus now, I don't know what is the oxidation number, right? So I will see the the final rule in my oxidation number, the last one. Okay, so the last one says that your Br is -1. How? Come, I show to you. Okay. Then you all say I'm not showing the evidence, can? Okay. This one. Okay. The oxidation number of element in group 17 in a compound is normally -1. Okay. You read the second one. The oxidation number of chlorine, bromine, is -1 except when they are bound to a more electronegative element such as oxygen. Thus, their oxidation number will have a positive value if they combine with oxygen lah. Okay, in this case your Br don't combine with oxygen, so we consider dia punya oxidation number adalah -1 lah. See your textbook giving a complete guide for you, -1. Then 2 KCl also I will see Cl only, so -1. Br2 same family, only Br, so 0. Okay, so you must compare them right now. Okay, wait, I close this one. So you must compare, right? Okay, see Cl2. You nak compare Cl2, which one? Dengan yang ini ke or dengan Br2? Of course lah, dengan Cl, same family only you can compare, man. So Cl2 dengan yang ini. So you see the oxidation number increase or decrease? Oxidation number decrease. So which process? Correct, reduction. Okay, this one, -1, then becomes 0. Sorry. Okay, -1 then become 0. Okay, so increase, correct? So this one is oxidation process. Okay, dah label kan? So now you must tell to me, in oxidation process, who is my agent? So for oxidation, I have what agent? Reducing agent, correct? So who is my reducing agent? For sure my substance lah, but whom? Cl2 ke KBr? Yang undergoes oxidation is KBr, right? So my reducing agent also my KBr, which is potassium bromide. Or you want to say bromide ion, can or cannot? Yes, can, because in this potassium bromide specifically that undergoes the reaction is bromide. So you want to say bromide ion also acceptable. If you want to say KBr, potassium bromide also acceptable only. Okay, for reduction, I have what agent? Oxidizing agent. Who is my oxidizing agent? Chlorine. So correct, right? Just now we learned your halogen will always become oxidizing agent. This is your halogen. This is your halide. So yes, correct. So your oxidizing agent is Cl2. Okay, so dapatlah. This is the concept there. So now you do the half equation and everything. So first I start half equation for oxidation. Okay, for oxidation. Okay, so for my oxidation, I start with Cl2, correct? Okay, so write the equation. My Cl, okay, Cl2 becomes what? Okay, becomes Cl minus lah. Ataupun if you feel lagi confused, okay, don't worry, take your table yang ini. Okay, wait mana table you? Okay, so this is the table, right? Okay, so you know that you punya oxidizing agent siapa? Chlorine. Find chlorine. Okay, study chlorine. Yeah, I found chlorine somewhere here. Okay, wait, I use cursor. Okay, this one, right? Okay, so this is the equation for chlorine. Chlorine undergoes what process? Reduction. Correct? Correct ke wrong? Yes, correct. So kalau dia undergoes reduction, I should take the equation dari belakang ke depan ke depan ke belakang. For sure, if reduction means I should take from front to back, because the whole equation in this table, if you take from front to back, it is for reduction. That is why this table is known as standard reduction potential also, because all the equations from front to back is for reduction. Saya dah ulang 2 kali dah. Okay, so write lah from front to back, right? So Cl2 plus 2E minus produces 2Cl minus, correct? Yes, 2Cl minus. Okay, then half equation for reduction. Okay, half equation. Wait. Betul ke? No. That is the issue. Alah, I salah. Okay, first one, dia undergoes reduction, correct? So that one is not half equation for oxidation. I just oxidation kan? No. It should be reduction. I'm sorry, I tersalah. Okay, I'm sorry. Okay, reduction. Okay, then this one KBr and also Br2. Okay, which dia undergoes oxidation. So this one is half equation for oxidation. So for oxidation, I must see whom? K ke Br? The one that involved is Br. So I must see Br. Carilah Br. Okay, so somewhere my Br is here. Okay, but undergoes oxidation, so I must write from back to front. So it will be 2Br minus, okay, 2Br minus produces Br2 plus 2 electrons. So this is my final answer. Okay, so jangan salah, always candidate punya mistake adalah for oxidation they take for potassium. Remember that your issue is between halogen and halide only. So you don't see apart from halogen and halide. Apart from halogen and halide, whatever you get is useless. Okay, so don't pandai-pandai nak tulis pula for potassium also. No need, it's wrong, consider wrong. Okay, so I already did my half equation for oxidation reduction. So now I must do my overall ionic equation. So my 2 sama lah, before arrow also I have 2, after arrow also I have 2. What the requirements to do my overall ionic equation? I must have 2 requirements. First requirement, in both of the equations, the number of electrons should be same. First one also 2e minus, second one also 2e minus. Okay, pass one requirement. Second requirement, the electron should be in 2 different position, meaning that, let's say for first one, the electron is before arrow. So for second one, kena after arrow lah. Dia kena macam tu, baru dikira betul. So write lah selebihnya. Cl2 plus 2Br minus produces 2Cl minus plus Br2. So done with your half equation also. So this is the complete explanation for your displacement of halogen and halide. Okay, so this is what they did here. So I already did for you at here. Okay, so you must understand the concept. So after this, if they question you anything from this half equation, let's say for reduction they ask you, so chlorine accepts electron or donate electron? Undergoes reduction ma, undergoes reduction means mestilah accept electron. Okay, oxidation, so oxidation means dia lost electron lah. So your bromine lost electron, sorry, your bromide lost electron. How many electron does it lost? 2 electrons. So remember, you jangan salah. So that's why I say, you see for oxidation, you ada bromide kan. So that's why I say kat sini kan, you want to write bromide ion pun lagi tepat, lagi specific, correct only, we accept only. But let's say you don't want to write in agent, you want to write KBr, still okay, you want to follow the chemical equation, okay je, no issues. Okay, so I rasa that's all for this video. We already done our level best of explanation. Or ada lagi apa-apa saya miss? Let me to check. Oh yeah, I miss something lagi. Okay, nasib I check. Okay, so come back for this observation. Sikit lagi ya. Okay, so we have potassium bromide, right? So potassium bromide ini, we have halide, correct? Bromide is halide. So initially potassium bromide what color? Colorless lah. Okay, because they are the halide. When your solution have halide, it is colorless. That's why your potassium bromide is colorless. But later change to brown. Why change to brown? You see here, the issue is between bromide and bromine, right? So what is bromine punya color? You memorize just now. Bromine punya color adalah reddish brown, but mostly in exam we write brown lah. Okay, so that's why the color change from colorless to brown. So if they ask the reason, because you form bromine, your final product is bromine. So you get bromine, so that's why the color is brown. Okay, then chlorine water. Chlorine water, what color chlorine water? Yes, chlorine water is greenish yellow color. Okay, then it become KCl. You can see right my arrow to here. So when the arrow is here, meaning that dia jadi halide. So for sure color dia adalah colorless masa halide. Understand? So this is the concept. So this is what they're trying to say with the observation. So you have to remember the color of your halogens. I repeat again, the color of your halogen, kalau I tulis, okay lah. I tulis lah. Okay. Chlorine is always greenish yellow. Okay. Tak kisahlah gas ke liquid, we will say them greenish yellow. Bromine, we will always say them reddish brown. But when comes to solution, we always prefer brown lah, okay? Because reddish brown ini dia tengok concentration. Kalau very concentrated, then we write reddish brown. So my advice for you is, for your level, untuk bagi tahu bromine punya color, you just write brown. Okay, it's good enough. Alright, so I rasa cukup lah. These two yang paling selalu naik kat exam. Okay, so for my students, my tuition students, I already explained the concept for you. So when I come to the class later, we will do quiz. Okay, so we will do quiz and we will see how. Okay, so that's all from this video. As your additional task, I want you to do what I did here for this one, which is for example 3 lah. Okay, because example 2 no reaction. So you help me to determine who is my oxidizing agent, who is my reducing agent, and then you tell me my half equation for reduction, half equation for oxidation. You do the overall ionic equation and you tell me the observation. Okay, I tell you again, you kena bagi tahu the observation for me. Observation is very important. So chlorine what color? I beritahu awal chlorine chlorine kan. So chlorine is greenish yellow. So dia punya partner adalah Cl- ni lah. Okay, so change to colorless. Ki colorless change to iodine punya color apa? You cari sendiri and you comment for me lah. Okay, so itu sahaja for this video. I will meet you guys in another one video with a new lesson. Okay, so that's it and bye.